Okay, so I'm starting for today's class. Can you hear me?
Yes, ma'am.
Okay, so uh, now, different types of non-random and random sampling process we have studied. So now we will discuss about the sampling distribution, means the distribution of sample value. Hmm. So that will be our aim to study. The sampling, first we will do that sampling distribution based on normal population. That means if your population is in normal distribution, then how the sampling distribution can be occurred. So there are different type of sampling distribution: chi-square, t-square distribution, chi-square distribution, t distribution, f distribution. So we will study one by one. So let x be the, if the x is the continuous random variable which follows the normal distribution with e of x is equal to mu and variance of x equal to sigma square. And if you consider a random sample of size small n, suppose these are the random values x1, x2 to xn, and they are to be drawn from a normal population, then the sampling distribution of different statistics. Sampling distribution of different statistics means that deals with sample. Uh, it is just a difference from the population parameter. In population, we discuss about the different parameter like mean, variance, like this. Similarly, in sample, if we discuss about the sample mean, if you discuss about the sample variance, then it will be called the sample statistics. So when the sampling distribution of different statistics which are useful in statistical inference are discussed, then we will go for the sampling distribution. Suppose x1, x2, xn, these are independently and identically distributed. They are all are independently distributed. They are not dependent to each other. They are independently distributed. Then sampling, what will be the sampling distribution of sample mean? Now we will go for the sampling distribution of different statistics like sample mean, sample variance, so on. So the sampling distribution of sample mean, if x and you know the what is the sample mean? Sample mean is the x bar, and sample mean means the uh, average of sample value, right? Sample mean is the average of sample value. So if x1, x2 up to xn, these are different sample values, then the sample mean x bar will be x summation of x x1, x2 up to xn by total number of samples. Suppose here it is seen that n number of small n number of samples are there because the sample size is small n. So we can say sample mean x bar is equal to summation of I equal to 1 to n by 1 by n, because total number of samples on by n. Then sampling distribution x bar is given like there will be different result we can say, because we know sample before understanding the different sampling distribution, we know about the different way of sample taken. Because sample is drawn in two ways, in SRSWR, that is
ম্যাম
simple
সরি, আমার
random.
একটু আসতে দেরি হয়েছে আজকে।
No, it's okay, no problem. আমি জাস্ট পড়াচ্ছি যে আমরা পপুলেশন ডিস্ট্রিবিউশন পড়েছি, আমরা স্যাম্পলিং মানে আমরা স্যাম্পলিং যে স্ট্যাটিস্টিক্স আছে সেই স্ট্যাটিস্টিক্স গুলো ডিস্ট্রিবিউশন দেখবো. So
ওকে ম্যাম।
first we are doing with the sample distribution of sample mean. Sample mean. This is also a statistics of sample. This is also statistics. Statistics মানে কি? Statistics আর parameter এর মধ্যে difference we know. Parameters means the different measurement deals with population. That is called parameter. Whereas statistics means the measurement deals with sample. একটা স্যাম্পলের মধ্যে যাবতীয় যা মেজারমেন্ট করবো, একটা স্যাম্পল আমার থাকলে অনেকগুলো স্যাম্পল ভ্যালুর মধ্যে আমি মিন বার করতে পারি, স্ট্যান্ডার্ড ডেভিয়েশন বার করতে পারি, ভ্যারিয়েন্স বার করতে পারি। দিস আর কল্ড statistics. But whereas in population, when we measure something like mean, standard deviation, variance, these are all population parameter. So population distribution আমরা পড়েছি, তাই না? বিভিন্ন পয়সন ডিস্ট্রিবিউশন, নর্মাল ডিস্ট্রিবিউশন, এক্সপোনেনশিয়াল ডিস্ট্রিবিউশন, rectangular distribution, different type of distribution we have studied. But in sample statistics, how the distribution occurs, that will be our concept. So if x1 to x2 to xn, these are different sample values of sample size small n, then the mean, sample mean can be calculated, and that is equal to summation of I equal to 1 to n by total number of sample, or by number sample size, that is small n. Then sampling distribution, before understanding the sampling distribution of sample mean, we first consider whether the sampling is done using simple random sampling with replacement or without replacement. And for different case, for these two case, we know the different value of sample mean, different value of standard error, right? Value of variance, right? So if x1, x2 to xn be random samples drawn by SRSWR, that is with replaceable, from a normal population, because already it is said you have based on normal population. That means your population is in normal distribution, which follows normal distribution of mean, with the two normal with the two population parameter mu and sigma square, because we know mu and sigma square are the population parameter of normal distribution. So if your samples x1 to xn are taken, are drawn by SRSWR from the population from the normal population with parameter mu and sigma square, then we can say the sample mean ভালো করে শোনো, then the sample mean will follow the normal population of mu and sigma square by n. This sigma square by n means because you are dealing with the sample. So this part you know, because in the last classes we have understood that for SRSWR, just a minute, I am just showing you. Yeah, for SRSWR, the sample variance is equal to sigma square by n, and the sample mean is equal to population mean mu. So similarly, it is shown here. It is shown here that if the random samples are in SRSWR from the normal population, then sample mean also follow the normal population, also estimate the normal population of mu and sigma square by n. And this Z factor, you know, it is already taught in the last chapter, that is Z is equal to x bar minus mu by sigma by root over n. Z is equal to আমরা জানি যে x bar minus mu by sigma by root over n. Actually, Z is equal to x bar minus mu by sigma by root over n means standard error by your what we'll say, that is standard error, by standard error that follows in normal population of 0, n, because we know that the it is already, if you go through the last chapter, theoretical probability distribution, there you can see that for population Z is equal to capital X minus mu by sigma. In case of population, it is already you know that is Z is equal to capital X means your X means a random variable minus mu by sigma. It is a normal variable Z, and expected value of Z, that is mean of Z, is equal to 0, and variance of Z was 1. This part already covered in the last chapter if you go for that. And these are called the standard normal variate or normal variate. Then similarly, in case of sample, we can say Z is equal to x bar minus mu by sigma by root over n, which will follow the normal probability distribution, that is with mean 0 and variance 1. And if this is the standard normal probability curve for Z, and if Z is symmetric by the mean value 0, then if this is Z alpha, and this is the upper critical value Z alpha, this is the lowest critical value minus Z alpha, and then you can say the notation Z alpha will be used to denote the value of Z, such that probability of Z greater than Z alpha will be alpha, because above the Z alpha critical value, it will be the probability will be alpha, and below the minus Z alpha critical value, probability will be alpha. And this part is the confidence, 100% confidence level. Then Z alpha, then probability of Z greater than Z alpha will be alpha, and probability of Z and probability of Z less than minus Z alpha is also alpha. Clear? Is it clear? এই পার্টটা তোমরা অলরেডি করেছো, সেই জন্য আমি একটা রিভিশন দিয়ে দিলাম। বুঝতে অসুবিধা হচ্ছে কোথাও?
না ম্যাম।
ঠিক আছে, আচ্ছা তাহলে this part is for if your sampling random sampling is with replacement, and for without replacement, you know, for without replacement, your variance, the variance of sample mean is the formula, you know, that is capital N minus N by capital N minus 1 sigma squared by N. এটা already আমাদের লাস্টে আমরা পড়িয়ে দিয়েছি, দেখো একবার ফর্মুলাটা মনে করে দিই যদি মনে না পড়ে। Right, this is the formula, right? When if you go for SWOR without replacement, then your expected value of x bar will be mu, and variance of sample mean will be capital N minus small n by capital N minus 1 sigma squared by n. So similarly for SRSWR, X bar will follow the normal population mu with mean mu and the variance N minus N by N minus 1 sigma square by N. Then obviously by following the same rule, we can say Z is equal to X bar minus mu by standard error. Standard error means this is variance, right? N minus 1 by N minus 1 sigma square by N. This is the variance. তাহলে আমার Z এর ফর্মুলা কি? Z এর ফর্মুলা হচ্ছে X minus mu by standard deviation. This is standard deviation. তাহলে সেই ফর্মুলা পুট করলে standard deviation means in case of sample distribution, we know the standard deviation means standard error. So we can say it is root over variance. So root over this variance will be the Z for SRSWOR. And if two independent samples of size N1 and N2 are drawn with replacement from two normal population of mu1 sigma 1, this is one population, this is another population. তাহলে কি বললাম? If two independent samples of size N1 and N2 are taken with replacement from these two population, from these two normal population, then the difference between the sample mean of these two sample size will follow the normal population with mean, the difference mu1 minus mu2, and the variance difference sigma 1 square by n1 and sigma 2 square by n2. Now, why the variance, the difference of variance is here, and why the plus sign is there? You may have the question, when I am finding out the sample mean difference, so it should follow the normal populations with mu difference and variance difference. But why the variance is plus? Why it is this sum, this symbol is not minus plus? Because the variance, you if you go for variance sum law, then the law denotes that the sigma square of difference, that is like this, uh, sigma square of difference. Difference may be x minus 1 or x plus 1, whatever be. That the rule, the law follows this sigma x square plus sigma y square. So this is the law. That is why in case of this also, the variance difference is nothing but the variance addition, sigma 1 square by n1 plus sigma 2 square by n2, because this follows the rule. This follows the rule. Clear? So similarly, we can say the z value, the standard normal variable z value will be equal to x bar minus mu. So ekhane x1 bar minus mu, x1 bar minus x2 bar minus mu means mu1 minus mu2 by standard error. So this is the variance. So standard error will be root over this. That is this one. So this is the Z. And similarly, if you go for without replacement, that also be similar to the previous value, because x1 bar minus x2 bar will follow the normal population with x mu1 minus mu2. Or for without replacement, we know the variance is equal to n minus n by n minus 1 sigma square by n, and variance difference is equal to will follow this formula. Variance difference will follow this formula. So we can say this variance of first population plus variance of second population. Clear? And now we can say Z will be equal to x bar minus mu. So difference of x bar minus difference of mu by root over this variance. That is root over this variance. Clear? So this is the formula. So this formula you have to remember just by writing 2 to 3 times. You can easily remember those formulas. Here. Now here numerical is given. That is, a continuous manufacturing process produces items whose weights are normally distributed with a mean weight of 800 grams and standard deviation of 300 grams. তাহলে এখান থেকে it is clear that the population mean and population standard deviation is given, right? A random sample of 16 items is to be drawn. 16 items of random sample, that is small n is given 16. Then what will be the probability that the sample mean exceeds 900 grams? This is your question. What should be the probability that the sample mean exceeds 900 grams? So your question will be like this. It looks like that probability in terms of equation. We can write probability of x bar greater than 900 grams. Clear? So, how can we write this? In terms of Z, we can write this x bar minus mu by sigma. Acha, here x bar by mu by sigma, that is in terms of uh, Z, we can write x bar minus mu by sigma by root n is greater than, তাহলে x বারটা কত দিয়েছে? x বার আমাকে বলেছে 900 গ্রাম, আর নিউটা দিয়েছে, পপুলেশন নিউ হচ্ছে 800 গ্রাম বাই standard deviation is 300, sigma 300 দিয়েছে, and by root over n by root over 16. Then you will have probability of z greater than 4 by 3. Acha, z 4 by 3 means 1.33. Probability of z greater than 1.33, and that is equal to, acha, probability of z greater than 1.33. Just see, if your probability curve will be like this, so probability of z greater than 1.33 will be in critical zone, right? So we can write write in this way, that is 1 minus probability of z less than equal to 1.33. It can be written like this, 1 minus probability of z greater than, because this part we don't know, right? So we know this part, that is probability of z less than equal to 1.33. This is known. So we can write probability of z greater than 1.33, because total probability curve is the total probability area will be 1. So 1 minus probability of z less than 1.33 will give you the probability of z greater than 1.33. So that is equal to 1 minus phi of 1.33. Achha. Do you know to find out this from the chart? Do you have this chart of different z value, the pi value? Do you have this chart?
Yes, ma'am.
Yes. Then you can from that chart you can see for z 1.33. Just a minute. Yes, for z 1.33, your pi of z will have the value 0.9082400. So in 4 decimal, we can write 0.9082. So that will be 0.0918. Clear? So that is the probability. This is the probability that the sample mean will exit 900 grams. Clear হয়েছে? বুঝতে পেরেছো নিউমেরিক্যালটা? দেখো এবার for the second case now, for second numerical, just see what are given. In a particular organization, there are 2000 employees. The average 2000 population is given, that is in capital N is 2000. The population is given. The average age of the employee is 40 years. That means your mu is given, that is 40 years. And the standard deviation of 5 years. That is sigma is already given 5. If a random sample of 100 employees is taken, then what is the probability? Random sample of 100 employees means your small n, sample size is 100. Then what is the probability that the sample will have an average age of less than 41 years? So how to write probability of average age? Means probability of x bar less than 41 years. This will be your question, right? So obviously it is, দেখো এখানে সব দিয়ে দেওয়া হয়েছে, ক্যাপিটাল N দিয়ে দিয়েছে, স্মল n দিয়েছে. So we will go for this formula, that is for without replacement, and that is root over, the standard deviation will be, the variance will be n minus n by n minus 1 sigma square by n. তো সেখান থেকে আমরা স্ট্যান্ডার্ড এরর বার করব. ক্লিয়ার? Just put the values and you will find out the standard error. Now, my question is, what will be the probability that the sample will have an average age less than 41 years? That is probability of X bar less than 41. This is my question. Then in terms of Z, we can write, because otherwise we cannot find out the value, probability value we cannot find, right? So in terms of Z, we can write probability of X bar minus mu by standard deviation. That means this one, right? So we do not write here in this form, that is less than X bar minus mu. So X bar is 41 minus mu. Mu is 40 by the standard error. That this is the value is already taken out, that is 0.4875. So your value will be probability of Z less than 2.05. So it is under your control. So probability of less than 2.05, you can easily find out, that is phi of 2.05. Clear আছে? এখানে যদি আমার থাকতো Z greater than 2.05, then I have to find out, because 1 minus, তখন 1 minus probability of Z less than 2 equal to 2.05 করতে হতো, because this is a critical value, critical zone. So we do not have this information. So in here it is not given. Here the simple it is Z less than 2.05. So this probability you can find out from the table. That is phi of 2.05, and the value is for the Z 2.05, phi value is 0.9798. So this is the probability that your sample mean will be less than 41 years. বলো। আচ্ছা, এটা খুব সিম্পল। এখানে দেখো, উইদাউট রিপ্লেসমেন্টে আমরা জানি আমাদের ফর্মুলাতে পপুলেশন মানে ক্যাপিটাল এন দিয়ে আসবে, তাই তো ফর্মুলাটা? উইদাউট রিপ্লেসমেন্টে ফর্মুলাটা মনে আছে তো? আর উইথ রিপ্লেসমেন্টে আমার সিগমা স্কয়ার বাই এন, তাই তো? সিগমা বাই রুট ওভার এন যদি স্ট্যান্ডার্ড এরর বলি। আদারওয়াইজ ভ্যারিয়েন্স হচ্ছে সিগমা স্কয়ার বাই এন। এখানে দেখুন, আপনাকে এখানে দেখো তোমাকে দিয়েই দিয়েছে পপুলেশন ভ্যালুটা দিয়ে দিয়েছে। এখানে কিন্তু কোথাও মেনশন করা নেই। এখানে কোথাও মেনশন করা আছে উইদাউট রিপ্লেসমেন্ট বা উইথ রিপ্লেসমেন্ট? কোথাও মেনশন করা নেই। কিন্তু আমাকে এখানে পপুলেশন মিন, পপুলেশন যদি ক্যাপিটাল এনটা দিয়ে দেওয়া হয়, তাহলে আমি এখানে আমাকে এই ফর্মুলাটাই আমি ইউজ করব। যদি আমাকে পপুলেশন ক্যাপিটাল এনটা দিয়ে দেওয়া হয়, পপুলেশন সাইজ, তাহলে আমি এই ফর্মুলাটাই ইউজ করব। দেখো এখানে কিন্তু কোথাও আমাকে এটা বলে দেয়নি। তো আমি এই ফর্মুলাটা ইউজ করব। আর দেখুন এখানেও দেখো তোমাকে কিন্তু কোথাও বলে দেওয়া হয়নি উইথ রিপ্লেসমেন্ট বা উইদাউট রিপ্লেসমেন্ট, বাট এখানে আমার পপুলেশন সাইজটা আননোন। সো তাহলে আমি ডিরেক্টলি সিগমা স্কয়ার বাই এন মানে উইথ রিপ্লেসমেন্ট দিয়ে করব। এটা নিজস্ব একটা মানে নিজে বুদ্ধি অ্যাপ্লাই করে অঙ্কগুলো করতে হবে, ঠিক আছে? আচ্ছা, তো তাহলে এতক্ষণ তোমরা বুঝতে পেরেছি। নাও we will come to the different sampling distribution. So first sampling distribution we will study, that is chi-square distribution. Now what is chi-square distribution? Actually the chi-square distribution, they are related to standard normal distribution. Clear? So there are different when you go for the sampling distribution of the sample of the statistics, then there will be different some different distribution. So there are some conditions when we will go for chi-square, when we will go for Z or T. So we will come according to that. So first we will go for some chi-square distribution. Just a minute. So if x1, if some random sample of size small n, if you draw from a normal population, normal population distribution, then the distribution of various statistics will also follow the standard distribution, like normal chi-square distribution, normal distribution, like this. Clear? So sample mean will follow the normal population. So if your main population follows normal population, normal distribution, then your sample will also follow the standard normal distribution. So chi-square distribution is related to standard normal distribution. If a random variable z, suppose you know about the random variable z, if random variable z has the standard normal distribution, z square has the chi-square distribution. If random variable, আবার ভালো করে বোঝো, if random variable z has the standard normal distribution, then z square will follow the chi-square distribution. So chi-square distribution, the random variable chi-square is said to follow the chi-square distribution with n number of degrees of freedom, and the chi-square distribution has the probability density function like this, that is function of xi square, function of chi square is equal to 1 by 2 to the power n by 2. This is gamma function n by 2. How this PDF comes, it is not in your syllabus, you do not need this, just you have to remember this formula, that it follows in this follows this PDF into e to the power minus xi square by 2, xi square to the power n by 2 minus. If you want to see, want to understand how this formula comes, you can go to YouTube. There are various lectures. They will show you how it comes. And xi square always follows the positive numbers, always follows the positive variables. Why? I will show you. So, and this is the gamma function. This is gamma function, gamma n by 2. So, how the gamma function works? Actually, if for gamma m, if your value is m, then gamma m will be nothing but m minus 1 factorial. So, gamma n by 2 will be n by 2 minus 1 factorial, like this. And gamma half is root over pi. So, the degrees of freedom already is in last class I told you what is the degree of freedom. It is nothing but the number of independent values that are just to estimate the statistics, the number of different values that are used to define the statistics, that is number of degree of freedom. So if x is a random variable which follows normal distribution, that is we are talking about the population. If x is a random variable which follows normal distribution with mean mu and variance sigma square, then we know that z is equal to the standard normal variable z is equal to x minus mu by sigma, and the expectation value of or mean value of z is 0 and variance is 1. Then what will be the z square? Z square will be like this, x minus mu whole square by sigma square, and z square will follow xi square distribution, chi square distribution with 1 degree of freedom, and it is denoted by chi1 square. Why? Because if you have z1 comma z2 comma z3 comma dot up to zk, if z1 z2 z up to zk are independent standard normal, are independent standard normal random variable, then we can say that Z1 square plus Z2 square up to plus ZK square will follow the chi-square distribution with k number of degree of freedom. Then degree of freedom will be k. So from this you can understand the number of independent value will be the number of degree of freedom. Clear? So number of independent value will follow the number of degree of freedom. So for individual z square, for individual z square, we can say, so for only, suppose this is z1 square, only one z, right? All z1 square. So it will follow the chi-square distribution with 1 degree of freedom. It can be said, because if here only we are talking about only one z square, then the degree of freedom will be what? Degree of freedom will be 1. For if you add, so add k number of z square, then your degree of freedom will be k, and for 1 it will be 1. So we can easily say for square of z, that is z square, x minus mu whole square by sigma square will follow the chi-square distribution. And if you go for 1 z square, then your degree of freedom will be 1. Suppose it follows chi1 square. Then what will be the range of this chi1 square or this z square? It always, distribution will always go on, always it will be from 0 to infinity, because if your standard deviation, if your if the z has this, if z follows this normal distribution, suppose this is z, this is 0, this is 1, this is 2, or this is 4, like this, and this is minus 2, this is minus 4. So if this is the curve, probability curve for z, then if you do z square, then your curve will be like this. Then your curve will be like this, because when you square it, then no negative value will be present, right? When you square, then no negative value will present, then you will have only the positive side, so you can have only this side, like this. That is why we can say as z square, as z square, if z follows the normal distribution, right? And z square follows the chi-square distribution. So we can say the so this is nothing but the chi-square distribution. So we can say for 1 degree of freedom, obviously, because we are doing only 1 times z square, right? This is so degree of freedom is only 1. So we can say the chi-square distribution is valid for 0 to infinity of z square value, of z square value of 0 to infinity. Clear? That is why it is said, the range of chi1 square is from 0 to infinity. So remember this, chi-square is always valid for 0 to infinity. So for different degree of freedom, for different number of degree of freedom, your what can I say? This the peak of this distribution will be different. For different value of degree of freedom, the peak of the distribution will be different. And so from this, the skew, right? Positive skew, negative skew. So remember, in chi-square distribution, the distribution always follows the positive skewed distribution. Always it follows positive skewed distribution. It follows the positive skewed distribution. So and the peak will be different for different number of degree of freedom. If your degree of freedom increases, then your peak will be decreases, and it will be like it will be decreases, and your entire distribution will be flattered. Entire distribution will be flattered. Your skew will be decreased, and entire distribution will be flattered. So the if Z1, Z2 to Zn, they are independent distribution of normal population 0 and 1, then your Zi square, summation of Zi square will follow the chi square. That is already I told you. That is I told you. It follows the chi square. It follows the chi square distribution. This is another type of distribution. Huh? And if x1, x2 up to xn are different in identical uh, identical uh, independently identically distributed with the parameter mu and sigma square, then we can say summation of I equal to 1 to n xi minus mu whole square by sigma square. That means z square. It is nothing but z square follows the chi-n square. And if you, in terms of sample, uh, if you, uh, if you uh, write in terms of small s. If you write in terms of small s, then your degree of freedom will be less than 1, right? Last class আমি বলেছিলাম small আমি এখানে হোয়াটসঅ্যাপে most probably পাঠিয়েছিলাম if you write this formula in terms of s, just a minute, I'm just showing you. If you write the formula in terms of s, yes, then your degree of freedom, then we know always we divide by in place of n, we divide by n minus 1. So simply your degree of freedom decreases by 1. It decreased by 1. In last class, I already show you some one example with degree of freedom. When we talk about sample and when we go for the variance, then we see you have to, we know that in case of sample, when you know about the sample mean, when the sample mean is known to you, when the sample mean is known to you, then your degree of freedom is not exactly as your sample size. Your degree of freedom will be decreased by 1 unit. So similarly, when you write those formula in terms of S square, we can say your chi-square distribution will have the degree of freedom 1 less than number of number of degree of freedom n. So chi n minus 1 square. It will be follow. And some important properties of chi-square distributions are as follows. The distribution is defined only by the parameter n, that is degrees of freedom. Clear? Just see in other distribution in normal population, we use two parameters. One is sigma square, another is n. But in chi-square distribution, we use only one parameter, that is small n, that is degree of freedom. And chi-square varies takes only non-negative values, obviously. That is why I have showed you chi-square values only only it allows the positive value, because when you are doing some square, the square of negative is always positive. That is why chi-square always follows the square of, always follows the positive non-negative values. And the mean of chi square, that mean of chi n square is equal to n, and the variance of chi n square of degree of freedom n will be 2 into number of degree of freedom. এটা মনে রাখবে for a case, if your chi-square distribution has degree of freedom 2, then its mean will be 2, and its variance will be uh, 2 multiplied by 2. So this formula, please remember, and the distribution is always positively skewed. Already I told you the distribution is always positively skewed because it flatters to the positive side. Clear? And the mode shifts to right and the curves gets flatter when the degree of freedom increases. যেটা আমি already বলেছে, if you increase the degree of freedom, your mode will be increased and your curve will be flattered. So the mode shifts to right and the curve gets flatter when the degree of freedom increases. This point number 4 is important for MCQ. And for large value of degree of freedom, root over 2 xi n square minus root over n minus 1 approximately follows standard normal distribution. And if xi n1 square and xi n2 square be two independent chi-square variate with n1 and n2 degree of freedom. If two different distribution are there, chi n1 square and chi n2 square with 2 degree of freedom, this is n1 freedom degree of freedom, and here for chi n2 it is degree of freedom is n2. Then the summation of chi n1 square plus chi n2 square is also a chi-square distribution with the degree of freedom will be n1 plus n. Clear? If you have two independent chi-square distribution with degree of freedom n1 and n2 respectively, then if you add these two chi-square distribution, then the total distribution will have the degree of freedom n1 plus n2. Clear? And chi alpha comma n square is also as it is the upper alpha point of chi-square distribution with n degree of freedom. So we can say from this curve, we can say probability of chi-square greater than chi alpha comma n square is equal to alpha, because this is the alpha probability, this is the alpha area. So probability of chi-square greater than chi alpha comma n square will be alpha. It is easy. Clear? So this is all about the chi-square distribution. This is the distribution of the statistics sample. Yeah. Then we will have t-square distribution, t distribution, f distribution, and that will be discussed in the next class. And in next class, probably we will complete the syllabus up to central distribution theory. Clear? If you have any queries, you may ask. Do you have any queries?
না।
আচ্ছা, তাহলে আর বলো যদি কিছু বলার থাকে, না হলে তোমরা লিস্ট করতে পারো। তাহলে ঠিক আছে, তাহলে আজকে আমরা এখানেই লিভ করছি। থ্যাংক ইউ অল।
থ্যাংক ইউ ম্যাম।